We're going to continue on with looking at the traversals using the graph data structure. We've already looked at the one for the iterative version of our breadth first. We've already looked at the iterative version of our breadth first traversal, but now we're going to take a look at the recursive version vis-a-vis the depth first traversal. So let's go ahead and take a look at how we're going to set that up. Now, because we're using the recursive version, we no longer had to keep track of that stack of information that we're using as that extra data, or that queue, of extra information. We're instead going to be using recursive calls to actually track what we're doing. So we have over here our previous version of our breadth first traversal. We have that information that goes along with that. We'll be coming back to that again and seeing what the difference is between that. So again, we're starting off with our same approach right here. We have the connected word, the name of our data structure we've been working with. We call the depth first traversal, passing the lovely graph itself, as well as what node we're going to start with, in this case 0, aka the 0th position of our array. That's where we're going to start off as the index for where we're going to go through that. So let's go ahead and take a look at what actually happens when we do this. So when we first start off with our lovely depth first traversal, the recursive thing, the first thing we have to set up is make a boolean array, and we make it called visited. And it's going to be filled with just a boolean array, easy peasy. Now, because we're just defaulting this with a size 7 just to test this out, we've got our lovely boolean array size 7, indices 0 through 6, right there, ready to go. And we, of course, assert that the index we're starting off with, in this case 0, is less than the maximum, which, I made it, so we're good to go. Our next thing we have to do is we're going to go use the fill end method of the standard library. We're going to fill out this lovely array, all with false, because we don't want to have anything in there yet, because we haven't got anything yet. So let's go ahead and make those all false. And that's the first step that we have to do as we go through that. The next thing we have is when we're going through our actual depth first traversal is we want to go ahead and now call depth first traversal, passing it our recursive method, passing it this array that we just created, as well as the graph and the vertex we're starting off, in this case 0. So we're going to start passing it 0, go right back in. And so once we go to that, we're going to then go and have a connections, which is a set, and we're going to use it to keep track of this. I'm just going to do a sub 0 right here. And so connection sub 0 are going to be the connections that exist from the 0th row, so the neighbors of our 0. So we go over here and we look at our adjacency matrix. And as you can see in our adjacency matrix, 0 has connections at 1, 2, 3, 4, but not 5, 6, or itself. So we're going to add that lovely set to our set right here. So 1, 2, 3, 4. And that's our connections, or our friends, or our neighbors that we're working with when we're looking at the actual 0 index. So we have that set up. Then we're going to take an iterator, and we're going to attach that iterator to this lovely set and go from there. And so the first thing we have to do is make sure that visited subvertex, aka 0, is going to be true. So first step that we have is we change that to be true. So we have a true value at 0. We are then going to go ahead and we are going to output that to our console, because that's where we're keeping track of our actual output for our traversal for that. And so sub 0 is CS. So we'll go ahead and put CS on there. So computer science is our first thing that we're putting inside that lovely output to our console. And then we're going to use a for loop to iterate over this lovely connections call, and then use that and go from there. So we're going to start off connections, we're going to start off at the begin, go until we're not at the end, and going up by 1 each time. So the standard way of using an iterative traversal data structure, right, that. So the first thing we have on there is we want to check to see on our first end connections, we're going to dereference that value, which is going to point to 1, because that's the first thing we have inside that. We're going to dereference that, it gets us down here, and we're going to see if we visited, which we haven't. So if we haven't visited, we're then going to recall the method of traversal, depth first traversal, passing it this new index. So we're going to call traversal with 1. So we're going to go back up. We're going to have new connections of 1. So we'll do a little 1 right here so we can show that it's going along with that. We're going to go over to the 1 index on our truth table. And if you notice right here, the 1 index is filled with false all the way through. 1 has no connections and it's making anything. So connections of 1 is going to be an empty set. Fantastic. So we have that empty set right there. Have the iterator. We're going to set visited 1 to become true. Next step on the list. And then we're going to go ahead and output 1. So output 1 is data structures. So we put data structures on our queue right there, just like we have already. And then our next step on there, we're going to go through and use that loop to go over that set. That set is then empty. Nothing in there could be possibly visited. So we have finished the call of the 1. So that this is now off the stack. We'll go ahead and draw a line through it, indicating we've left the stack. We're going to go up to our next spot, going to 2. Our recursive call. So we're going to have then the next step was the connections of 2. So we go over here. We look at 2. We grab its neighbors, and 2 has a neighbor at 6. Oh, fantastic. So we get 6 inside that lovely connection. That's the 2 neighbors. Our next step that we have on that is we're going to create an iterator over this, mark 2 as a visited spot. So true becomes visited. We then go ahead and say C++ pointers is our thing we're going to output to the console. And so we've got that right there. The next thing we're going to do is going to iterate over that lovely connections, that neighbors of the 2, which gets us to 6. Okay, so we're inside 6. We're going to go ahead and grab that. So we're going to iterate over 6. And have we visited 6? Oh, no, I have not. So that means I'm going to go down and call a depth first traversal on 6. So now I'm going to go down over here to 6. My new call gets me in here. And I have a neighbor at 2. So I'm going to go over here. And 6. 6's neighbor is 2. And I'm going to go through and I'm going to say, okay, I have my lovely little set right here, and I'm going to look at my visited sub 6 as it can become true. I'm going to take 6's value, which is the dereference operator, put that into the thing. Dereference. And I have that marked off right there. I am then going to finish, have I visited 2 already? Well, yes, I have. So I'm not going to do anything up. My 6 call is then finished. I'm going to come back up to my 2 call. My 2 call, I finished that. So I'm going to go ahead and exit that lovely structure. So I'm going to go up and now, and I'm going to my next iterator. My iterator is now pointing to 3. Then I'm looking at that. So I'm going to go over here to 3. And my 3 vertex, I'm going to go ahead and, have I visited 3 yet? No, I have not. So I'm going to call depth first traversal on 3. So that means I grab a new thing right here, connections. And we're going to look at 3. We go over to 3, and I have falses all the way through, so I have a new empty set. Okay, fantastic. I'm going to set visited 3 to become true. I'm going to go ahead and I have print out 3 for this, so 3 over here is Java Rocks. And then I'm going to come up, and my iterator of 3, there's nothing to go over that, so I'm just going to go wipe that straight out. 3's done. I'm out of that. So the next thing you do is move my pointer of my original call back up here from sub 0 to go over to 4. My connection points to 4. I'm going to go ahead and now I'm going to set my, have I visited 4 before? No, I have not. So I'm going to go make the new call, grab 4's collection, and I go over here to 4. I have 4. I have a connection only at 5, so I'll fill that with 5 inside the connection right here. So I have 5 that's inside that. I'm going to now iterate over that connection set right here. Okay, have I visited 5 before? No, I have not, so I'm going to put 5 in here. So I make the call to 5. I come through. And did I skip that on 4? Oh, I did. Could I go get the 4? Hey, have to do my call to 4, not my call to 5. So I have my depth first call to 4. Helps if I put that in the right one. So 4. So I haven't visited, and I haven't visited 4 before, so that means I depth first onto 4. I go over here. I'm going to go and I'm going to grab my lovely things, which gets me 5. Gets me my connections. Okay. And so I haven't visited that. I go inside there. I then visited 4. That becomes true. Okay. So I've got true. I output my 4th value on here. So 4 on here is swift as nifty. I then go through and iterate over 4's set, which is 5. So I'm going to go over here to 5, have it, and I'm hit 4 is 5. Have I traversed 5 before? No, I have not. So I'm going to make a call to 5. 5 comes in here, and 5, its only pattern right here is inside 4. So I'll grab 4, put that back in. So in 5's call, I have 4. 4 is, I look at that. I check to see, looking over my lovely neighbors of 4, or my neighbors of 5, I have 4. Have I visited that before? Okay, so I'm going to come in here. I'm going to grab my visited 5 becomes true, so that becomes a true right there. I'm going to put 5's value, which is the arrow indicator, is the return operator for Swift. And I have that right there. I've got that out. I'm then going to go iterate over that lovely section of 4. 4 is inside here. Have I look at that thing? Have I traversed that location? Yes, I have, so there's no recursive call. I pop out of that. I'm going to pop back out of that because I've now finished that call. Nothing left to do on there, which gets me out of here, which means I pop out of this call, so I've traversed all those spots inside that connection, and I've traversed all locations inside my array. So let's go ahead and take a look at the results of that. On my depth first console, I start with my 0 position. I have my 1 position. I have my 2 position. Okay, 0, 1, 2, fantastic. But then I skip over here to 6. Oh, a little bit different compared to the 0, 1, 2, 3, 4, 6, 5. So as you can see, the traversals give us a different set of information, what ends up actually happening within the actual traversal structure. And so the depth first traversal, because we're using the recursive calls to keep track of where we're going, those calls grab us different neighbors than if we're simply going to use the breadth first traversal and keep that queue of information. And so looking at the way these different traversals traverse that information, we can get different results and make different connections between that. And so that's what we're looking at for the next bit. Thanks.